Alrighty, looks like we're about ready to get started. Let's go ahead and talk about solving some logarithmic equations. And when we're solving a logarithmic equation, we're going to do things like, isolate all of our logarithms on one side. We're going to use our properties of logs to consolidate into a single expression. And then we're going to rewrite it into an exponential equation. So, like I say, we're going to isolate our logs on one side. We're going to combine into a single expression, and we're we're going to rewrite. We're basically going to convert it into an exponential expression. And then from there, we're going to solve, and it's very important that we check our answer. So let's show you a good example of this. And I'm going to do something fairly easy right now. So say I've got like first example, log base 5 of x plus log base 5 of 3, and let's have that equal to 1. So remember, with our properties of logs, a sum of logs with the same base means that I am going to multiply together the log ends. So this is going to be x times 3. So I'm still going to have log base 5, but this is going to be x times 3. Oh, it'll be a 3x is equal to 1. So this is all simplified into a single one. And now I'm going to rewrite this as an exponential expression. So this property was, or was that, remember it was that log base b of x plus log base b of y is equal to that log base log base b of xy. Here, this property is more of, well, this is just the identity. So we're saying that if I've got my base, the answer is my exponent. So here I'm rewriting this 5 to the first is equal to that 3x. So I've got 5 to the first power is equal to 3x. So remember, if I've got log base b of x equals y, then I'm going to rewrite that as b to the y is equal to x. So again, base stays the base. The answer was our exponent, and that becomes that log end. So here we go. Well, from here, 5 to the first is just 5. And with this, I just need to divide both sides by 3. So we're good. So I've got 5/3 is equal to my x. And we're done right here. Now, if I were checking this, I would just plug in this in for my x, and we're going to see something interesting happen. So when I check, part of what we're checking for is, remember, we can never have a negative. We can never take the logarithm of a negative or a 0. So this value always has to be positive. And one of the things we're going to see here is, oh, that's going to be log base 5 of that 5/3 plus that log base 5 of 3 is 1. Oh, this is just subtracting. So this is going to be log base 5 of 5 minus log base 5 of 3 plus log base 5 of 3. I'm sorry, that's equal to 1, equals 1. And sure enough, negative log base 5 of 3 plus log base 5 of 3 is just 0. And log base 5 of 5 is just going to be 1. What to the what to the first power equals 5? Or 5 to what power is equal to 5? Well, that would be 1. So I've got 1 equal to 1. So our answer checks out. All right, let's do it again. Let's give that another try. Let's go ahead and do something like sorry, that was log base 3 of x minus log base 3 of 2, and let's have that equal to 2. Okay, again, our properties of logs. So remember, if it's subtraction, I'm going to be dividing, and whatever I'm subtracting, that's going to be that numerator. So this is going to turn into log base 3 of x over 2, and that's equal to that 2. And again, that property was said that if I've got log base b of x minus log base b of y, this is the same thing as that log base b of x over y. So that quotient rule for our logarithms. This is that property. And again, we're going to go ahead and rewrite this. This is going to be 3 to the second is equal to that x over 2. So I've got 3 to the second is equal to x over 2. Well, I actually need to evaluate 3 to the second. That's going to be 3 times 3, which is going to be 9. 9 is equal to x over 2. And then from here, I just multiply both sides by that denominator. So when I multiply both sides by 2, I've got, 2 times y or 2 times 9 is 18 is equal to my x. And we're done. And just a quick check, it looks like, sure enough, that would work. If I were to do this, I could say, oh, that's going to be, if I were to, I can tell that whatever I've got right here, that's positive. This answer is positive, so we're good. So we can see that this, in fact, would be positive. This is doable. And if I just at a quick thought, just thinking about this, looking at that, just for a check, log base 3 of 18 minus log base 3 of 2 equal to that 2 equal to 2. This is 3, 18 is 3 squared times 2, so this is going to be log base 3 of 3 squared plus log base 3 of 2 minus log base 3 of 2 is equal to 2. And sure enough, those cancel out. And log base 3 of 3 squared is going to be 2. So 2 is going to be equal to 2. Our answer checks out. Let's do a slightly trickier one now. And I'm going to stick with log base 2 for a second. So I've got log base 2 of x plus 2 plus log base 2 of x equal to 3. And this one's interesting. So again, I've got two different factors, and this is going to end up being, well, log base 2 of x times x plus 2. I'll just go ahead and write that as x times x plus 2. And that's equal to this 3. Now I'm going to rewrite this as an exponent. So 2 to the third is equal to that log end. So that's x times my x plus 2. Well, 2 to the third, that's an 8. That's equal to, let me go ahead and distribute that. That's going to be x squared plus 2x. Oh, this looks like something we know how to solve. If I subtract 8 from both sides, I'll end up with 0 is equal to x squared plus 2x minus 8. Looks like looks like I can factor and solve this. And looks like with a key number here of -8, I've got a positive and negative. It's going to be, it looks like I've got like -1 and 8. That doesn't do it. -2 and 4. That does. So this would turn into x minus 2 and x plus 4 equal to 0. X minus 2 equals 0 gives me a solution of x equals 2. X plus 4 equals 0 gives me a solution of -4. And so I've got two different solutions here. And if I look at this, I'll end up with, gosh, log of 2. That'll be, so if I put in a 2 here, that'll be log base 2 of 2 plus 2. Okay, that'll be log of 4. Log base 2 of 2 is 1. Log base 2 of 4 is 2 plus 1 is 3. So this one, that one looks like it's going to check out. The -4, yeah, I'll just go ahead and run these. So that's yeah, log base 2 of 2 plus 2 plus log base 2 of 2 equals 3. And sure enough, log base 2 of 4 plus log base 2 of 2 equals 3. 2 to the second is equal to 4, so that's a 2. 2 to the first equals 2. Yes, that equals 3. Sure enough, that looks like good math. And on this one, a -4, right off the bat, we see problems. -4 plus 2 plus log base 2 of -4. There is no power on 2 I could put that would give me a -4. So this doesn't work, which means that this one is an extraneous solution. So I only have one solution of x equals 2. Alrighty. Last example. Let's do something along the lines of, how about I do log base 5 of x plus 2 minus a log base 5 of x is equal to 1. All right, again, we're going to put our logs together. We're going to put that into one expression. So this is going to be log base 5. Since this is subtraction, this term is going to be in my denominator. The added one is going to be in my numerator. So that's x plus 2 over x is equal to, or log base 5 of x plus 2 over x is equal to 1. And now 5 to the first is equal to that log end. So I've got x plus 2 over x. Well, 5 to the first is just 5. Now I'm going to take both sides. I'm going to multiply both sides by x. What do I have? Oh, that's going to be, in this case, I'm going to have 5x is equal to x plus 2. All right, I'll subtract x from both sides. We've got 4x is equal to 2. I'll divide both sides by 4. And I've got x is equal to 1/2. And it looks to me like, yes, that will probably end up working because we'll end up with, if I were to, as long as this is not negative and it doesn't make a negative in here, that means that we're probably going to be okay. So I'm just going to conditionally say that is likely to be true. And if I think about that, 2.5, because this would be 2.5 divided by 1/2, that would be 5. and log base 5 of 5 would be 1. Alrighty. Thanks for tuning in, and we will see you in the next video.